this is Mr. Shahrukh here. It's a wonderful to be back with you. Today we shall begin our online session with one of the important topic from Standard 12th, that is matrices. This video includes the required concepts of 11th standard as well. So let us begin with our online session. Hope you all will enjoy it. Now let us revise some concepts from previous class. In previous class, we have seen types of matrices, in which the first one was row matrix. Now what is the row matrix? A row matrix is a matrix in which we have one single row and n number of columns where n is greater than equal 1. The second one was column matrix. Similar to the row matrix, we have a column matrix in which we have one single column and m rows where m is greater than equal 1. Now if a matrix contain a single element, then it is either a row matrix as well as a column matrix. It satisfies both the definitions. The third type is zero matrix or a null matrix. A null matrix or a zero matrix is a matrix in which every element is 0 and it is denoted by O. The fourth one is a square matrix. A matrix in which number of rows and number of columns are same. That means it has an order where the number of rows and number of columns are same. Next one is a diagonal matrix, that is the fifth type. A diagonal matrix satisfies the property of a square matrix. So a diagonal matrix is always a square matrix, and here non-diagonal elements are always 0. Next type is scalar matrix. A scalar matrix is a diagonal matrix in which each and every element of a diagonal is same. The next one is seventh one, that is unit or identity matrix. In a unit or identity matrix, we have all the elements of diagonal as 1. Upper triangular matrix. A square matrix in which every element below the diagonal is 0 is called an upper triangular matrix. If you will observe the diagonal, that is 409, below which all the elements are 0. Ninth type is lower triangular matrix. A square matrix in which every element above the diagonal is 0 is called as lower triangular matrix. Tenth one is triangular matrix. A square matrix which is either a lower triangular matrix or upper triangular matrix is called as triangular matrix. 11th type is symmetric matrix. A symmetric matrix is a matrix in which the elements above the diagonal and below the diagonal are same. Means if you see this H and H, these are same. This element and this element will be same, that is denoted by G, and this F and F will have the position will have the same element. Such type of matrix is called symmetric matrix. Now what is the meaning of skew symmetric matrix? Skew symmetric matrix is of similar type as that of symmetric matrix, only it will have opposite sign. It means above and below the diagonal the elements will be same, only their sign will change. If this position have negative sign, it will have positive. If this is positive, this will have negative. Here it is negative, so here it is positive. The 13th type is determinant of a matrix. We all have learned how to find the determinant of a matrix. A square matrix whose determinant can be found can be written like this. It is mod of B, or just two vertical lines, between that we have to write B and all the elements between that, and after that we all know the procedure of finding the determinant.
14th type is singular matrix. A matrix should be a square matrix And if the determinant of that square matrix is 0, then we say the matrix is a singular matrix. If the determinant of that matrix is not 0, then we say it is non-singular matrix. It is one of the important concept of matrices. We need it. Okay, so keep this in mind. Next one is transpose of a matrix. That is the last type of the matrix. In this, what happens is we interchange the columns with rows or rows with columns, and it is written as A transpose, A raised to T, okay, or A dash, okay. Both has the same meaning. Now if you'll observe, this column has written as row, okay. So this was the revision for types of matrices. Now let us move to the algebra of matrices. In algebra of matrices, we have four concepts. The first one is equality of matrices. What is the meaning of equality of matrices? We say two matrices are equal if both the matrices have same order and the corresponding elements of both the matrix must be same. The second concept, third concept and fourth concept we will see with one example each. Okay, so these are the three operations. We will be looking at the examples of these three operations. Addition of two matrices. Addition of two matrices means we will add the two matrices by adding the corresponding elements of each matrices. So here we have a matrix A and matrix B. So let us find A plus B. Okay, so how to find A plus B? What is the matrix A? Matrix A is given to us, that is 2, 3, 1, -1, -2 and 0. Okay, and matrix B is given, that is -4, 3, 1, 5, 7, -8. We have to add it to it, so that will be plus -4, 3, 1, 5, 7, -8. Let's add them by adding the corresponding elements. So corresponding elements means the first elements will be added to the first element, second element will be added to the second one, and third element will be added to the third one, and so on. So that will be 2 plus -4, next 3 plus 3, next 1 plus 1. Now second row, that will be -1 plus 5, -2 plus 7 and 0 plus -8. Now let's simplify this, and what do we get? We get a new matrix, that is 2 minus 4, that is -2, 3 plus 3, that is 6, 1 plus 1, that is 2, -1 plus 5, that is 4, -2 plus 7, that is 5, 0 minus 8 is -8. So this is addition of two matrices. Hope you all have understood the addition of two matrices. Now we will turn towards multiplication of a matrix by a scalar. Now here, what is the matrix given to us? Matrix given to us is A, and what is the scalar over here? Scalar is 3 by 2. What is the meaning of scalar? Scalar means any number. So here we have given 3 by 2. Now we have to multiply matrix A by a scalar, that is 3 by 2. So let us multiply our matrix by a scalar, that is 3 by 2. So that gives us 3 by 2A, means 3 by 2. And what is the matrix? A, that is -1, 5, 3, -2, 4, 7. Okay. Now multiplying each element of the matrix by the scalar given to us, that is 3 by 2. So that will give me by 2 into -1, that is -3 by 2. 5 into 3 by 2, that is 15 by 2. Next 3 by 2 into 3, that is 9 by 2. Next 3 by 2 into -2, that is -6 by 2. Next 4 3s are 12, that 12 by 2, and 7 3s are 21 by 2. Let us simplify it further. What do we get? We get -3 by 2, 15 by 2, 9 by 2 minus 3. Here it will be 6. 21 by 2. So this was multiplication of a matrix by a scalar. I hope everyone understood this also. Okay, now we will go to the next concept, that is matrix multiplication. Now matrix multiplication is one of the most important concept in the matrices which we will need in 12th standard as well. Whereas all these operations are used everywhere, but this is the most used operation. So be careful while multiplying the matrices. Now here two matrices are given to us, matrix A and matrix B. What is the order of matrix A? Order of matrix A is 2 by 2. And what is the order of matrix B? That is 2 by 3. Okay. Now here you need to observe one thing. Column of the first matrix and rows of the second matrix must be same. If they are same, then only we will be able to multiply them. Now, therefore we can find multiplication of matrix A with B. So that will be, what is matrix A? 1, 2, 4, 3. What is matrix B? 1 minus 1, 2, 0 minus 1, 3. Okay. Now we will be multiplying these two matrix, and a new matrix which we will be finding out. We can identify the order of that matrix by looking at the order of the previous matrix. So here if you'll see, number of rows in matrix A and number of columns in matrix B. So our new matrix will be of order 2 by 3. Keep this in mind. Okay. Let's when we'll find out the complete solution, we will just cross verify this. Okay. Now, what is the method of multiplying the two matrices? Now, here the method is, we will be taking first row and we will multiplying with each column of the second matrix. Now, I have taken the first row and I will multiply with the first column. So that will be 1 into 1 plus 2 into 0. Okay. Now again, first row, second column. So that will be 1 into minus 1 plus 2 into minus 1. Now again, first row and third column. It will be 1 into 2 plus 2 into 3. Now, first row is done with all the columns. Now, let's go to the second row with first column now. So, 4 into 1 plus 3 into 0. Now, again, second row with second column. 4 into minus 1 plus 3 into minus 1. Now, second row and third column. Now 4 into 2 plus 3 into 3, right? Now that gives us a new matrix, that is 1, that will be minus 3. Here it is 2 plus 6, that is 8. Here it will be 4, here it will be minus 7, here it will be 17. This is the new matrix. Just check out the order, 2 rows and 3 columns, 2 by 3. That is what I told you in the beginning. Yes. Okay.